So just, and we have a bit more time on this one. So how many of you have ever used WebKit for programming? Anything? WebKit GTK or Qt WebKit? GTK? GTK? No, no GTK on this side. How many can program in C and C++? At least some. How many know about G-Object and GTK in general? A fewer? Yeah, so I will try to go slow. Maybe we're not finishing everything, but the goal of this talk is to take the fear of a big project. So even if you have a giant code base, it's still possible that you can make changes to it and approach it without having to understand everything. And this brings us to the second goal, which is a small guide of how you can start to understand a big code base just by starting in one area and slowly starting to understand more of it. And we will look into different things today. First of all, we will try to figure out what WebKit is. I assume that many people know what it's used for, so we will look into the project itself, and then we will go through the directory structure to figure out what we do have in WebKit and what it's used for, how the WebKit GTK API is built, and after this we will start to enter the WebKit source tree through the Webkit Webview and try to understand how things work. We're obviously not doing to finish all of this, but I hope it's going to be a nice introduction to approaching big projects and figuring out how Webkit GTK works. So instead of telling you what Webkit GTK is really about, I start with the soft facts. In our project, we have the status of a reviewer. So if you make a patch to WebKit and you want it to be included, you need to have a reviewer looking at your change and giving you a plus in the bug tracker on this patch so it can be committed. And right now we have, I sloppily counted on the wiki, we have about 77 reviewers. It grew a lot in the last year with Google and others. On top of these 77 reviewers, we have 100 committers. These people have direct commit access to the source repository, but they're still required to get review on all the patches. So once they have reviews, they can actually commit codes themselves. We do have the notion of a port, which means making WebKit work on a specific platform. This can be Qt or GTK or WX or an operating system like Windows, Windows CE or things like that. And right now we have 8 ports inside our tree with varying degree of completeness. Apple and Google are the main contributors of the project. Actually, I think Apple did a lot of work in the last years, but Google is really catching up because they're throwing many people onto the WebKit project. And we have many commits a day. So it's really active and things move on. If you don't look for a week, you're sometimes amazed of what has changed in the tree. To repeat this, a platform port responsibility is to run on a specific system. And in contrast to many other systems that try to run on different systems, we don't have a very high-level abstraction layer, but we give a lot of freedom to platforms to use the best possible components of their system. One example is the recent animation work and graphics layer support by Apple. They want to use core graphics and their frameworks on OS 10, and of course they don't exist on Linux or somewhere else. And the two options a project would have would be to either go for a high-level abstraction, to have a generic layer framework and things and lose performance on the way, or just directly use core graphics and figure out how to make it work on different platforms later. And we generally go for the best solution for one platform first, and then try to figure out how to abstract it and make it work for others as well. And this kind of freedom for the port allows us to directly use the toolkit for many things. So in Webkit GTK, we use, of course, GTK to have a widget. We use Cairo for painting. We use ATK for accessibility support. We use libsoup, which was previously only used in Evolution to do our HTTP stuff. Empathy is wrong. I forgot the real name for the library to check spelling. So we can use a lot of GNOME infrastructure in our port without forcing anyone else to do it. So we get the best out of WebKit. And as a project, we're quite open. So we use the IRC channel on Freenode to communicate. We do have mailing lists for development. We do have a mailing list for help questions. So if you want to write content or you're using any of the WebKits, we do have a mailing list you can ask questions for. And most of the patches and bug fixes and progress are done in Bugzilla. So yeah, we have quite some mailing lists nowadays, ranging from people searching WebKit developers to GTK specific questions to development, to JavaScript development. Yeah. Sorry. So in general, if we want to start looking at the source directory now, we so just a quick LS inside the source tree. It reveals certain core components, which is JavaScript Core, which is the JavaScript engine of WebKit. We do have WebCore, which holds all the HTML parsing codes, the tokenizing of it, creating a DOM tree from that, and then creating a tree for displaying things. It contains event handling, editing support. Actually, WebCore really holds everything which is related to web technologies. Then we do have the WebKit directory, which is only present to provide API on to third-party developers. And we follow a way that is known from Linux. So everything in the WebKit directory, the API we export, is pretty stable. You can rely on it being like binary compatible, source compatible, or whatever the port is promising. So this is going to change stay stable. And everything in WebCore is in flux. We break interfaces, we rearrange code, so it's not like in other projects where you use COM inside the rendering engine and have COM interfaces that communicate to each other. We do direct function calls, and we change the internal stuff all the time. Then we do have a directory with layout tests and expected results, which is inside layout tests, which are run every time someone makes a change on the tree. We run through the test suite, which actually right now contains 800 megabytes in tests and results. We can take a look at the current tree status on the build board. So we can see it works on Mac. Snow Leopard is broken. So some timeouts. On Windows it looks bad too. How's GTK doing? Oh, GTK, everything is green, which is very nice. So on every change we run through these layout tests and verify that things render the way they rendered before, which means a web page is going to look the same as it did before. And finally, also an important directory is the Webkit Tools. And they contain tools that help us in development or users in compiling WebKit. So inside scripts, we do have some Perl scripts to build WebKit somewhere at the top. Yeah, so far. So one of the most important scripts for users to get started is build WebKit that actually helps you in building WebKit for your platform. And JavaScript Core is responsible for JavaScript, which is probably coming as a surprise, but it's really used for that. The interpreter contains the JavaScript interpreter. The JIT contains the just-in-time compilation code. JavaScript is at the bottom of our stack, so JavaScript Core depends on nothing, and everything else in WebCore and WebKit depends on it. And we do have a cross-platform template library framework, which is called WTF, Web Template Framework, which contains a lot of common code like hash trees or vectors or traits for certain things, and also a threading abstraction. Yeah, we see that we have something which is related to threads, hash tables, type traits, vectors, and one can also see subdirectories like WinCE, WX, Mac, or probably GTK at the top. Yeah, GTK, G-Object. So these directories contain implementations that are specific to a given port. Okay. The next biggest part of WebKit is actually the WebCore directory, which is responsible for everything. Mostly, it contains the HTML parsing, the DOM tree handling, SVG editing, layout, the code for printing. So anything which is related to the engine itself is inside the WebCore directory. And it's written in C++ in a portable way that it can directly compile with GCC or Visual Studio or Intel compilers or anything. And it doesn't use any platform-specific types or libraries or functions. This is achieved by having a platform abstraction which works by having a generic header file and a platform-specific implementation. So this way we can have an engine which compiles against different subsystems without having the problem of creating components to deal with each other. Sorry, let's go back one slide again and look into the WebCore directory. we can see like a subdirectory history, which obviously is related to browsing history. HTML contains the HTML code. Inspector holds the WebKit inspector you might have seen. The loader is responsible for triggering loading of pages. Workers are related to JavaScript worker script. XML is related to XML parsing. Page is related to having a page with a viewport and painting or starting to paint and handling events. MassML obviously for MassML support. And all this is handled in really a generic C++ way that doesn't rely on any specific platform. The next bit is really what users of WebKit see, which is the API exported by a specific platform. So to put it in contrast, we have this webcode directory, which is just generic C++ code, but someone who's using Qt wants to use a Q widget or an API which blends perfectly into the Qt world, or someone on Mac wants to use Objective-C to interface with WebKit, or on GTK, of course, we want to use C and GObject and GTK widget. And the way we achieve this kind of integration is by having a platform-specific API, which can provide a stable interface to the GTK world, but uses internal types inside the implementation. So as soon as we have a major port, a directory inside WebKit will pop up, and this is how I counted existing ports. So we have one for Chromium API, one for EFL, GTK, a port to the Heiko operating system, Mac support, Qt support, Windows, WX, and of course GTK. And in general, the platform integration works by having two subdirectories, or in this case more, but one is to provide the actual API of the port, which we have for the GTK port inside the WebKit directory. For Qt, this would be inside the API directory. And then we do have a directory called webcore support, which holds code that is supposed to be platform specific and AP specific, but helps to bridge and deal with, or is used by code in webcore. So we get into specifics on how the platform integration is going to work right now. Wow, 2 of you are already sleeping. That's amazing. I will get all of you. So we start diving into the WebKit tree by looking at the high level class called Webkit Webview. This is a GTK widget you're going to embed into your application if you want to display content. And in general, it works by holding one main frame. So like a Webkit Webview has one Webkit web frame, and a Webkit frame can, depending on the content, hold a tree of frames. So every frame can have a tree of child frames, thanks to the frame element from HTML. And so the Webkit Webview in our port is responsible to give users of our library a way to easily embed a HTML component. We are going to allow people sorry, getting out of sync with my 2 views. So we allow users of our API to access settings that control that if a user can allow to access local files or which font size to use and these things. And we do send signals from this Webkit Webview on frame loaded or copy or pasted or things like this. Internally, it works by wrapping a class called WebCore page, which sits in the WebCore namespace, indicating that it comes from the WebCore directory. And we can just look into the GTK code a bit. And because we only know a symbol name, we will just set a breakpoint in the main method. Then I'm going, let me interrupt this for a second. I forgot one important thing. I want it to display in a different window. Okay, so I'm because I have no idea of how it's going to work, but I know the class name and I know the init function for GObject. I will use GDB to start exploring this thing. So I'm going to set a breakpoint in main just to make GDB load all the symbols which are loaded by the application. And now I can use tab completion, hopefully. So all our symbols are prefixed with Webkit, and because we know it's a Webkit Webview, we can type this. And the next thing is GObject calls an init function when an object is constructed, and we have set the pointer, so we can set a breakpoint in here. And you really need to have a fast machine to do Webkit development. The debug library is something like 300 megabytes in size. And my fan starts spinning. Anybody wants to make GDB faster? I'm really getting impatient. It worked. it worked a lot faster before. Finally, it found the breakpoint. So now I'm just going to continue. And we have hit the breakpoint. So we can make a backtrace to see who's calling it. I was using an application called GTK Launcher, which is just a small application around the Webkit Webview. So we will see that this browser called Webkit Webview, which called GObject new, which then figured out which type to create, and finally called our pointer. And using list, I can see the code. So the first thing we do is apparently initialize a GTK input method context. So let's just single step through it. We set a private pointer. And then we use something called page clients. And we all see that they are coming from the Webkit namespace. They're all coming from the Webkit namespace, so we actually know just by this convention that it must come out from the WebCore support directory of our tree. And finally, a WebCore page, like a page here, is created with these clients. And just by looking at the name, some are probably obvious. Inspector, we have a Webkit inspector, so the client is used by the Webkit inspector inside the tree. A drag client could be probably drag and drop of your application. So the drag client is most likely handling the drag and drop of the engine. Editor client is responsible for editing So especially in Asia, we need to have input method context. So you type single characters, but you want them to be grouped into one Chinese character, and this should be handled in the editor client. We do have a context menu client, a Chrome client. We don't actually know what it is. It doesn't relate to Google Chromium. They just use this name because it's a generic browser term. And after this line now, we have created a page. The next thing we're doing is creating a web inspector type from our GTK class. Then we're setting something on it. Adjustments for scrolling, taking ownership of them. We want to be focusable. And now we create a WebKit web frame. And as I thought, like every WebKit Webview has one frame, so obviously this is going to be the main frame. So I just want to set a breakpoint there as well, and I will continue, and now I'm getting called on it. And this one is a bit cheating. It's using object new to create a web frame, but it's doing most of the initialization in this class. So it should be moved into the init function, and there's a fix me in the code, but actually no one has cared to do it. So here we see another thing called client, which is a frame loader client. So we are inside a web frame, and we create a loader client. So it must relate to loading pages and resources into the frame. And we will figure out what it's doing, hopefully later in this talk. And then we're creating the first web core frame, giving the client we have created over here, and assign this to a local pointer inside our type. And we call init on the web core frame, and we are back in the Webkit view init. This is the settings we're going to apply or we want to use on the page. By default, we have the default settings and colors, and we're updating the status on them. Yeah, and then we're almost at the end. So we are at the end of the method, and we have initialized a Webkit Webview, and it holds a Webkit web frame. And if I just continue, I messed up the display. We have a browser frame coming up. So the next thing is the abstraction layer doesn't have like an event loop abstraction or types stuff. In contrast, everything gets pushed into the WebCore framework. So for painting, we do have expose handling in GTK, and widget gets exposed, and we will forward the exposed region to make sense for WebCore, and then we start painting in these areas. Event handling works again because we're like this, because we are a GTK widget. We handle all the input events GTK is handling, and we push it into the web view. And this should have shown up in, yeah, actually it shows up in Zephyr, so I can debug event handling without deadlocking myself and needing to reboot my session. So to figure out where we want to look, we can go into the Webkit directive for our API. So it must be the GTK subdirectory, and then Webkit, and we know we want to go to Webkit Webview. I missed one subdirectory, so Webkit Webview, which is actually C++ code because we need to use webcode types, but the external interface is just plain C. And we can just search for the name mouse. Let's search for expose. We have seen a function, and everybody who has done GTK programming should be known to this, or should know this kind of source code. This is getting called once when a class gets created. Ooh. We have a lot of signals. Very much. Did you know we have so many signals? Okay, so this is called the first time a class in the G-object model gets initialized. And we call Webkit init, and we install all the signals we have, nicely documented with GTK doc and even mentioning when it was added. And we can go down to the expose handling as well. So in our class, we want to handle a lot of things, like choose file, script alarm, which is really specific to the WebView class. And for the general G-object class, we want to handle special things for garbage collection and dispose and finalize, setting properties, getting properties. For the widget class, we finally see all this code. So we have a specific handler for the expose event. We do have one for key presses, or key release, button press, scrolling, focus handling. So we can just take a look into the key press event handler. And we know this function, and I'm going to use this as a breakpoint. So I'm using GDB again to set my breakpoint. Now I can type continue. And all I have to do here is to press a key, and GDB should halt in this breakpoint. And luckily it does. And I can see who called me, which has a long history, but somehow the window got a key press and figured out that we are the focus item and we need to handle it. So I'm just stopping here. I can see the code which is around me. So the first thing is from the widget which was active. We know it must be a Webkit Webview, so we will cast it to the Webview. We are extracting the focus controller and figure out inside our Webkit Webview which frame was clicked on. And then we construct a platform-specific platform keyboard event. So we transform, or we have an adapter to go from a GTK event to a specific platform event, this time for keyboard. And the constructor actually knows what to extract from the types. So we can try to step in there. Let's try again. Okay, we just remember the GTK event inside this class. The next thing is to see if we have a display, like a view for the frame. We can have frames which were loaded but were never rendered and have no visual context assigned, and there's no point in clicking on it. Actually, it's going to crash if we do. So we have to check if we had frame view, and then we're calling on the frame. We use the class event handler and call key event on it. So the inside the key event handler in WebCore. So we have now crossed the boundary from WebKit code to WebCore specific code. And inside this handler, we're now trying to find the node which was clicked on, which is just handled by event target node for document or first, and then we're trying to find this node, most likely. So we have found the node we want to display, or we want to send this event to, and then we call an editor class to handle this keyboard event. So in case of Chinese, our editor client that we have seen before will most likely get called, and so we can just make another breakpoint, and we see that the first thing this editor is doing is trying to get an editor client, and then it's calling into the editor client. So we can try to step in there, and we have seen that we sent an event from the WebKit layer down into WebCore. It tries to figure out where it sends the keyboard event to, and from WebKit or from the WebCore directory, calls back into the WebKit world by using this client system. So in this case, for the editor handle input, it's just a proxy method to use the editor client to call back into WebKit code, and we see it's coming from Webkit core support. Yeah, and then we will probably start to do a composition and let GTK figure out how to deal with keyboard composition and continue. So the important lesson from here is to understand how we get an event in the GTK world, convert it into a platform-specific keyboard event, platform key event, then send it down into WebCore to dispatch. And if WebCore needs to get like support from the platform API and higher widget hierarchy, like input method support, it calls back through a client into the GTK world. Okay. So, and in the previous GDB session, I think I got half of them sleeping now. And in the previous session, we have seen that we created a web frame, and in our case, a web frame is just a G object because we want to emit signals like the frame loaded, or do you want to load this page into this frame questions. So we had to make it a G object, and the responsibility of the web frame is to wrap the WebCore frame and to send the signals. And the fundamental concept there's one thing we use a lot. This is this client concept I showed before. So a general rule of our abstraction is that WebCore should not know about types we use in the Webkit directory. But sometimes the code in WebCore needs to interact with the platform-specific GUI and API code. In example, in JavaScript, you can ask for the size of the frame, and you need to make it possible. So we use this client system. In general, it's a pure virtual class. It's the way to do interfaces in C++. And the client gets passed to an object when the object is instantiated. And the implementation actually sits inside the WebCore support directory. So this way we have an interface in WebCore that can be used by all WebCore types, but have the implementation platform specific integrated into WebKit inside the WebCore support directory. And I can just execute this as well to see that we really use this concept a lot. So I'm just quitting this text editor and I'm trying to find the code inside the WebCore directory. So I'm fine. So I'm looking in WebCore and I'm searching for everything which is called client.h. And we do use this a lot for many things. So we use it for editor client, for input method handling. We use it for drag and drop, for context menus, for providing the geolocation to WebCore. Two things I haven't seen before: device orientation and device motion. Scrollbar client for handling scrollbars, but that's internal. Web inspector client. We really use this concept everywhere where we need to would use WebKit types inside WebCore, but then go for the client thing. No. So one of the most famous ones we're seeing inside the page and frame are the Chrome client, which is responsible to provide information to JavaScript, like what is the size of the frame, am I focused or am I not focused, or to handle the prompt that you can do in JavaScript to get model feedback of, like, you want a number, you can use prompt in JavaScript and show it. This is dispatched through the Chrome client. The frame loader client is really responsible for loading, and because it's a client, it can do policy. So every time we try to navigate to a new page, in example, a user has clicked on a link, the frame loader client is asked, do you want to open this page? And this, of course, needs to be handled in a platform-specific way and even exported to the API. So sometimes in Epiphany, if I press Control and open a new link, I want it to be opened in a new tab. So we need to be able to send this navigation into the WebKit layer. And of course, drag client for drag and drop, editor for input methods. So in one example, to understand how the client really works, is to look into the frame loader client, which is called for frame loading. So the interface sits inside the WebCore directory. And everything should be a pure virtual function, and this one is not. And there's a reason for it not to be. Okay. So everything else should be pure virtual. Okay. And this is called from a class called FrameLoader. So every time we use a client, we have a something client.h header file with the interface. We do have a something.h and CPP implementation, which is using the client to do the work. And finally, we do have an implementation for GTK inside the Webkit directory. So it's Webkit GTK WebCore support and FrameLoader client GTK CPP. And there's a lot of things. So in example, emitting a signal when the load status finished or the load was done, or even stuff that is not implemented by us and we probably don't want to implement or should implement at some point. And we do emit a lot of signals from this class as well, like progress for page loading. Or the policy check I mentioned, which is using a signal with a return value, so people can decide if they want to handle it or not. Yeah. And Chrome client is in a similar way. So the implementation sits in WebCore support again, and the important things like JavaScript can ask for the window rect of the screen or of the widget, and we use the GTK widget to do it. Or JavaScript can ask to have the window resized to a specific size, and we're emitting a signal, or we're just setting it and see if it can be auto-resized, and if it can't be auto-resized, we will just stop it, and if it can be resized, we move it and resize. JavaScript can grab focus or unfocus widgets, or it can ask to open a new page in a window, and we do the same. We get a web view back from the call where it should be opened. Can run modal. Yeah, JavaScript can control if the toolbar should be visible, and we're just handling it by setting a property, which can be connected by the notify framework of GObject. Yeah, so Chrome client is actually the bridge from the stuff which is around the web frame to the JavaScript world. Okay, so we have seen how the GTK widget interacts with the web core to send in events. The other thing comes from the button on how is web core actually drawing, and for this we also just use a generic way. So in all cases we have abstractions. An example for painting, we do have a class called graphics context, and we have different implementations depending on the platform. So we do have this platform directory which is responsible for the platform integration, and we have subdirectories. One is for graphics, and inside graphics we do have this generic interface called graphics context, even 3D, but just this one. And we do have port-specific or library-specific subdirectories. So for GTK, we're using Cairo to paint, which means we do have a Cairo subdirectory, and an implementation which has the graphics context base name to show where it's coming from, and the port name suffix, so you can differentiate from the file name which port it's using. So the concept is we do have a generic header file inside one of these platform directories, and we do have a specific implementation inside inside a subdirectory, which is then suffixed with Cairo or whatever the port is. And we're using the same for text and Unicode handling, for network abstraction, and sometimes when we don't implement a specific function, or if a new function is added to the platform abstraction, people will put not implemented macro inside these functions, and they get printed by when running into this function. So you get a log message, blah 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 function is not implemented, and it's a great way to get started to code. If you see it not implemented, you can figure out if you want to implement it, and if you decide that this pod wants to implement a function, you can just try to implement it and send a patch, which really is a very nice way to get started, because it's just one function, and there's a test case that is testing this function, and you can easily get started doing this. And for networking, we have two more classes. So one is the resource request, which holds the URL you want to open, HTTP headers, or if you want to make a post with like a form attached, you have also the form data into the request. And then we do have this platform-specific class called resource handle. And the resource handle gets a resource request, and it can also get a resource handle client assigned, which is again the same client model. So whenever we have some information to dispatch, like we have started to load or we have received data, the resource handle client is called with the specific functions. For GTK, we're using libsoup, so we do have the directory called Web Core Platforms Network Soup, and there should be a resource handle class inside there. And again, it's called resource handle, and then the suffix for the library used. And the start implementation figures out if it's worth loading something into a page, is then getting the URL from the request, the protocol, and soup is actually only handling HTTP, so for local files we have to fall back to GIO, which is done over here. So for HTTP we start the job as a soup request. So we get the default session and convert a request into a soup message, and then connect to signals. Then handle uploads of files. An example, if you want to upload a picture to Flickr or somewhere else. More handling of this. Then we take a reference count on it. And finally, we're sending off the information. And to provide callbacks and to provide information when something was downloaded, we're getting, so this function is called when this resource was closed from GIO in this case. We get the resource handle client, and we call did finish loading on the client. So whoever is making a request provides a resource handle client, and whenever the request is handled, the client is getting called with the data or with the information it asked for. Good. It's almost 6 minutes before time, so I can either continue with fonts, or are there any questions regarding WebKit, GTK, or to what I said? I know it was pretty technical, and just with one guy ever having used WebKit GTK for an application, it's a bit too much. But do you have questions regarding the port integration or state of WebKit in general? Or a short mentioning, there's going to be a more high-level talk by San Lopez in about 30 minutes. Or so if you want to see more what you can do with WebKit GTK, this talk is more interesting. Anything? Otherwise, I'm going to ask random questions to you, or you have to take a test, or.
Oh no, I awake. I have a question about the GIO API. Does GIO depending on GNOME volume management? I mean, if you want to use the GIO to write the local files, do you need GNOME supporting, GNOME supporting? Or
I think some can correct me if I'm wrong, but for GIO you can have different modules to provide access, and I think the file module is inside glib.
So it's just inside glib?
It's glib.
Okay, thank you.
One issue most people have with trying to compile glibs themselves and then trying to get WebKit run on a device is GIO tries to determine the MIME type based on the extension, and you need to have XDG desktop files on MIME type info installed, otherwise nothing will load into your page. It happens like once a month or twice to people. Okay, then I'm going to ask a question. What was the biggest... Please go ahead. I think he was first, to be honest.
I wonder how do you handle HTTPS and do you have the handle the FTP or other protocol?
This is the nice thing. There are two things. First of all, if you do encryption in the US, you have problems with export. So once you become a committer to WebKit, you have to sign an agreement that you're never adding encryption code to WebKit. So we don't have HTTPS support in WebKit, but we solely rely on the base library to support it. So in this case, in WebKit GTK, we use soup, and for every request we make, we export the soup handle to the higher levels, and soup needs to handle HTTPS and provide callbacks about the certificates and other things. So it's done by the base library. Please go ahead.
Hello, I would like to ask similar questions. Is there any advantage to use libsoup because there are many existing HTTP libraries, and some of them can support more protocols such as CURL library. So is there any advantage to use this?
At the beginning, we have used curl inside WebKit GTK, but the one reason is we never had good integration with the event loop with curl, so we had to add a timer that we poll curl every 100 milliseconds. So by using libsoup, we do have glib event loop integration. So we get immediately called if there are data in the socket. So by using libsoup, we have better integration with GTK and glib.
还有人醒着吗？还有问题要问吗？
Yeah, behind you.
I have a question about the JavaScript engine. I know you have to tell us there is a JavaScript engine in the WebKit, but is there any definition of interface about JavaScript key that JavaScript engine so we can change to other script engine?
You want to change the JavaScript engine?
Yeah, is there any standard interface?
Like everything inside WebCore is pretty much in flux, so there's not going to be a stable interface. But of course, Google managed to hook up their V8 into WebKit. So there is some kind of abstraction between the JavaScript engine and the WebCore things, but it's going to change every day, so there's nothing stable.
Okay.
At some point there were patches for WebKit GTK to make use of V8, but they were not merged because nobody wanted to maintain them.
Okay, thank you.
Okay, I have one question. I have 1 minute left. So how many of you have worked on a project with like 1,000 lines of code? None of you? No, at least 1,000 lines of code. 10,000? Should I go logarithmic? 100,000? Millions lines of codes? No? Nobody works on Linux kernel here, or one? Yeah. So I assume you're all software engineers to some degree, right? So what is the biggest project or open source project you have worked on? Anything big? Sorry, stupid questions. Then. Okay, then I have no more questions.
如果没有其他问题，是不是表示说大家想要放出去吃甜点的这样子？
Please go ahead.
I got another question. It's also about the network protocols because as I know, some GIO modules, the GVFS1 can support some additional protocols. So maybe you can consider implement the FTP support with it. Yeah.
Yes, we could.
Is there any plan for this?
Well, no plan from my side, but sometimes I go to FTP and I'm annoyed that it doesn't work in Epiphany. So the place where it could be changed is, we do check for FTP support, but it doesn't work. So
Yeah, that doesn't work. We are working on what you said. So we are working on making libsoup handle different types of protocols internally. So you can tell libsoup what to do with FTP or whatever you want. So we are working on it.
As soon as possible.
Soon.
Please.
Sorry, I got another question because I'm curious about the performance of libsoup and the Webkit GTK implementation because from my experience, sometimes GIO and something libsoup or some glib integration with its main loop can be slower sometimes. Since you mix the network transportation with the GUI main thread, it can make things slower, or you handle this with multi-threading.
I think soup internally is using threads, or no, only DNS lookups and threads. Nothing, but I see many threads being created in GDB. That's Webkit.
There is I just checked // there's a comparison of performance between Firefox 4 Alpha 2 I think and Conqueror using Webkit. I didn't read, but it seems actually it runs faster than Firefox. I don't know if you have internet. You can go online and check. The thing is on /. today, so you'll see Webkit is not that bad after all.
Well, it depends on the platform integration.
Yeah.
In general, if you do things multi-threaded, you need to have locking and you need to dispatch jobs to threads, and it's in most cases a lot of overhead and a lot of work to get it right. And so far, I have not seen that we run into a bottleneck with soup and message or in loading things, because soup is doing everything asynchronous. So if there's nothing from the socket, soup will not be doing anything, and if there's data, we directly read it and send it into WebCore, which is certainly faster than dispatching it to a different thread. But if you have a specific benchmark where you think soup is the problem of download speed, then we can certainly look at it.
嗯哼，没有问题了吗？再思考一下。如果没有的话，那我们要感谢一下讲师。好，这时候中文想说英语场景打下英文的，好，谢谢讲师。那接下来呢，有一段休息的时间。再来我们是3点半的议程，由 Muller 要来做讲解的动作。